Hey everyone! So I thought we could look at some practice AP questions. And notice, find the area of R. Ooh, that was from the last chapter. We should still know how to do that. Write, but do not evaluate an integral expression that gives you the volume of the solid when R is rotated around the line y equals 7. See, Kukla wasn't just being mean. Nice. And then R is the base of a solid. Cross sections of the solid taken perpendicular to the y-axis. Ooh, not to the x-axis, but to the y-axis. These are our footprint problems. Is a rectangle whose height is 3 times the length of its base in R, right? But do not evaluate an integral. Okay, so I think you should give it a try. Pause the video and give it a try. 15 minutes. That's what you're expected to be able to do this in. I don't really care if you can do it in 15 minutes now, because I know that if you are working on this stuff, you'll be able to do this easily in 7-8 minutes by the time you get to the AP exam. We have 2 full packets about area and volume. Woohoo! All right, can't wait. So, give it a try. Come back in less than 15 minutes. Hey, welcome back. So, this is our region. This is y equals 6. This is 9, 6. That curve is y equals 2 root x. And all we want is the area. And so remember, we said we could find area by adding up all these lengths. And these lengths, which are changing, could always be found by doing top minus bottom. Okay, and we're drawing this way, right? So these are dx. So my top is this line, 6, and my bottom is this curve, 2 root x. That's top minus bottom. I want to integrate that from this x value to this x value, 0 to 9 dx. Okay, and yes, I do think it helps if I write that as x to the 1/2 after I figured out what the integral should be. Antiderivative of 6 is 6x. Antiderivative of x to the 1/2. Well, if I bring down that 3/2, I don't see a 3/2 here. So 2/3 times 2, I guess that's going to be 4/3. So that when I bring down the 3/2, tink, 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 and I'm going to put 2. Good. And that's a minus. Okay, and we're integrating from 0 to 9. 6 times 9 is 54. 9, square root of 9 is 3. 3 to the 3rd is 27. 27 divided by 3 is 9. Times 4 is 36. And that's going to be 18. So the area of R is 18. All right, there's part A. Now what about part B? Wait. Yeah, I was just wondering. I didn't put the top is 6, 2 root x dx, and we went from 0 to 9 at 6x. Yeah, so when I plug in zeros into each of those antiderivatives, 0 and 0. That's what I was concerned about. All right, what's next? Write but do not evaluate integral expression when we rotate this around y equals 7. Okay, so they didn't specify. So I'm going to show both, and you can decide which you like better. So if I'm doing washers, I've got a little r, that is 7 minus 6, or 1. And I've got a big R here. Well, this distance is y, this distance is 6, and so big R is going to be 6 minus y. The thickness, however, is measured as a horizontal dx. So let's call that 6 minus 2 root x. It did say here that all I had to do was set up. You don't have to try and evaluate it, right? But do not evaluate. And so we've got 6 minus 2 root x squared minus 1 squared dx. And that means we're integrating from here to here, 0 to 9, and don't leave out that pi. Okay, that seemed pretty straightforward. What if we did that problem with shells? Okay, let's envision it again. We've got this region here, and we're rotating around y equals 7. So we'll draw something parallel to the axis of rotation. Now, this distance is y, this distance is 7, and so my radius, well, radius is going to be 7 minus y. And I'm okay with that because the thickness is vertical. This is a dy integral, and so I'm okay with that. How about the height? Well, the height is my x value. So what is y equal? I know that y is 2 root x, or y over 2 equals root x, or y squared over 4 equals x. So my height is going to be y squared over 4. Okay, so what's that integral going to look like? We're going to pi the radius here was 7 minus y, and the height was y squared over 4 dy. And since we're integrating dy, we want to go from here to here, not to 7. We're integrating the region, not to 7. I mean, you can put 7 if you want, but you're going to lose that point, and you don't want to lose that point. We're only integrating the region. Okay? Okay. So that's problem number B, or letter B, done 2 different ways. You choose whichever you think would be easier. And then the last one, this time, we're taking this region, and they say they would like us to make some rectangles that are perpendicular to the y-axis. And the height of that rectangle is 3 times this distance here. Well, if this is an ordered pair called x, y, that distance is x. And so the height must be 3x. The area would be then 3x squared. Uh-oh, these are slices like this. That has to be a dy. So I'm going to have to get rid of x and replace with y. What was this curve again? This was y equals 2 root x. Oh yeah, and we said that x then was going to be y squared over 4. Okay, I need x squared, so I'm going to take y squared over 4 and squared. So that'll be y to the 4th over 16 equals x squared. So my integral then, I'll lose that 3. 3/16 y to the 4th dy, and we're integrating from here to here, 0 to 6. No pies, sorry, that's not a circle-y shape, that's a rectangle. Okay, yeah, so how do we do? Well, the whole video has been running for 9 minutes, so I guess we made it in under 15. Just to go through the scoring here, we haven't talked about scoring. Part A, look, we got that answer too. Good job, us. 1 point for the integrand. Now, integrand, the stuff behind the integral symbol. You're getting 1 point just for doing top minus bottom. I mean, come on. Talk about sweet points. Antiderivative. Well, we've got our top minus bottom, and can we do a correct antiderivative of that? That gets us another point. And the third point is the answer, that we can use FTC2 to evaluate that antiderivative and get 18. If you left this calculation, what was it, 6x minus 4/3 x to the 3/2, right? And we were plugging in a 0 and I think it was a 9. We had 54 minus 36. That is okay. This is not okay. This does not get the point. No, not okay. Sorry, you're lazy. Even College Board says that. But, if you plug that 9 in and get 54 minus 36 minus 0 minus 0, that's fine. That earns the answer point. Okay, next, B. This was when we were rotating around y equals 7. 2 points for the integrand. Well, we're getting 2 points, one for big R, one for little r, and no, you don't have to write this as 7 minus 6, though you could. Yeah. I do want to say that, notice, there's no shell version here. That's okay. If you write the shell, you're getting 1 point for the radius and 1 point for the height. Finally, then, we get our third point for limits and constant. Constant, if we're doing washers, that constant is a pi. If we're doing shells, we should have a 2 pi out here. And the limits, they mean the boundaries for our integration. So 0 to 9 for washers and 0 to 6 for shells, because we're doing dy. Okay, finally then, we're looking at this rectangle that we just did. And again, they say 2 points for the integrand, 2 points for the stuff behind that integral symbol. So, yeah, I need to come up with this. And notice how they're telling me that's the base, and the height is 3 times that. You don't have to exactly have that, and I don't remember, sadly, how they split the points there. I imagine that in the classroom is a folder in one of the file cabinets that actually tells us, because I was at that meeting. And then finally, 1 point for the answer. And so, yes, we do have to, we write but do not evaluate? So that's what we want. That is getting us our answer point. Okay, so not an answer that's a numerical value, just an answer that is, in fact, the integral. And that was from 2010. Okay, so how about then we look at this one? Wow. This one is from 2009. We've got a little region here between this linear function and this curvy one, which is, dear friend, y equals x squared. Thanks for coming on this journey with us. And look, find the area of R. I think you can find the area of that region. R is the base of the solid. For the solid, at each x cross-section perpendicular to the x-axis, that's a little more familiar, has an area of sine pi over 2x. Find the volume of the solid. I wonder what you're going to do with that. Okay, and then another solid has the same base as R. But this time, cross-sections perpendicular to the y-axis are squares, right? But do not evaluate the integral expression. So, why don't you pause the video now, give yourself 15 minutes, give these 3 problems a try, and really, I know we're on the 6th day of this, and you you will have either feelings of, I got this, or I almost got this, or I still don't have this. Hey, if you're in still don't have this, you probably need to be asking a lot more questions and doing a lot more of the practice. Because I bet if you do all the practice and you ask all the questions that you have when you have them, this will go much easier. And don't worry, by the time you get to the regular AP exam, like I said in the last video, you're going to have actually 2 full review packets. I mean, it's going to be something like 20 questions, 25 questions, like this, 25 of these to get through. So breathe and just work and learn. Those are the things I ask. Okay, so if you haven't already, pause and do this problem because I'd like to get it started. All right, we've got y equals 2x. We've got y equals x squared. Where do these meet? Well, 2x equals x squared. X squared minus 2x. X minus 2. Well, at 0 and at 2. So this is the point 24 up here. Okay, oh, and it's even labeled in the picture. So we want to find the area for R. And so I'm adding up all these slices. So I'm going to do top minus bottom. So integral of 2x minus x squared dx from 0 to that x value, 2. And we have to actually find the area. So we do need the antiderivative, x squared minus x to the third over 3 from 0 to 2. So 2 squared is 4, 2 to the third is 8 thirds, minus, and I plug in my zeros. That can be my answer. I can stop there. Or I can make a common denominator. 12 thirds minus 8 thirds is 4 thirds. So the area of R is 4 thirds. There's no units given here, so just leave that number if you feel compelled. You could put units squared if you want to, but you don't have to. Okay, there's part A. What about part B? Part B says the region is some sort of solid, and we're drawing these things, and I don't know what that region is. I mean, really, it could be like turnip-shaped things for all I know. What I know is that this area is, A of x is sine of pi over 2 x. Okay, and remember, and one of the reasons I said it that many times, when we're looking for volume, we're integrating area. Okay, we want to integrate area. That's what we're doing here. So, what's our area in this situation? Well, that's interesting. That's a different thing. Oh, sorry, just checking at my answers. And I'm not seeing something that makes sense here. So let's, okay. So what's area? This is area. And notice I have dx, so 0 to 2 of sine pi over 2x dx. I think that that's all there is to this. But it's good to be sure. So let me just quickly check that. And we said this was 2009. Yeah, 2009. Okay. So, what do I see here for this problem? There it is. Yeah, that's it. That's the area. And I think a lot of people, like I almost did, want to make this much harder than it is. And one of the reasons I keep telling you that volume is simply integrating area is so that when they give you some sort of funky area, yeah, you just know, I don't care. I'm not going to be thrown off by this. I'm just going to integrate that area function. Now, this is something I can do by hand, right? So you might want to use a u sub with pi over 2x. So du is pi over 2 dx. And so I can rewrite this integral as the sine of u du pi over 2 du. So let's pull that pi over 2 out in front. Sine u du. Hey, what would our u bounds be? Let's take this x bound and plug it in here. 0 times this is 0. And let's take that x bound and plug it in here. 2 times pi over 2 is going to be pi. So what's my antiderivative here? Well, the antiderivative of sine is negative cosine. And that's a u. And I'm going to evaluate the u. And I get that. So cosine of pi is, it's definitely not enough space. Let's go up here. So we have negative pi over 2 times cosine of pi minus cosine of 0. Well, cosine of pi is negative 1 minus cosine of 0 is 1 times negative pi over 2. That's going to be negative 2 times negative pi over 2, which is going to be pi. Our volume is pi. Okay, nice and tidy. What did I miss? Because I'm looking at something else there in the answer. Did I lose a constant? This pi over 2 is here. But shouldn't it be 2 over pi? Oh, yeah. Yeah, look. I replaced the dx with pi over 2 du. But dx, ooh, kukla, you forgot that. So this should be 2 over pi. Okay, and how does that change this? This is 2 over pi. This stuff is all still the same. It's 2 over pi. So this is minus 2 times minus 2 is positive 4 over pi. Phew. Okay. And the third part here, part C, we've got this, y equals 2x, and this, y equals x squared. And remember that this point was 2, 4. Okay, and what are we supposed to do here? Cross sections perpendicular to the y-axis are squares. Okay, so this is a side length, and to find it, I'm going to do right minus left. Now, remember, the slices are going this way, so I need things that say x equals, because this is the x value for that curve. X equals y over 2. Okay, so L is the left one, this one over here. Okay, now R is this one, right? This is the right side, this is the left side. The right side, this is the x value. And so that equals square root of y. And so the side length then is going to be square root of y minus y over 2. And we want to integrate that square root of y minus y over 2. Don't forget, this is side, but we're integrating area. And so we need side squared, because that's the area of this shape is side squared. And these are dy's, and we're going from y equals 0 to y equals 4. Okie doke. Okie doke. Yeah, so let's take a look at the scoring here. For this one, we're getting 2 points for the integrand. And I don't recall if that's 1, 1 or 1, 1. But we're going to need both of those. And the limits, 0 to 4. Because a lot of people are going to go 0 to 2. Even though they say these things are perpendicular, perpendicular to the y-axis. So we should definitely have dy's here. Okay, the part B, where we just had to integrate area. So that one, I love that one. So we had sine of pi over 2x dx. This is integrating area, and we went from 0 to 2 here. And so what did we get? We get 1 point for remembering to integrate area. We get 1 point for the antiderivative. And that's where I made my mistake, so I would not be getting that point. We should have negative 2 over pi cosine pi over 2x. And then 1 point for the correct answer, which is 4 over pi. Now I will say, there are lots of situations where if you have 2 over pi, pi over 2 here, they may very well be told, yes, they can read with your mistake. You already lost that point for the antiderivative. And sometimes they say, yeah, if you lose that point, we're done reading. But sometimes they say, read along with the student. So I would have to use your wrong antiderivative to see if your answer was consistent with your wrong antiderivative, and then you'd get that point if it was. So don't freak out at most. I would have lost that 1 point, not 2 there. And finally, part A, where we were looking for the area of R, that was just a top minus bottom kind of thing. And again, here we're getting 1 point for the integrand, and the integrand in that problem was, as I said, top minus bottom. And so we're getting 1 point for that. 1 point for top minus bottom. We're getting 1 point to do that antiderivative. And then we're getting 1 point for coming up with the correct answer by using FTC 2. Now, don't do this. This is not sufficient for the third part. Yeah, no, we need to see you plugging stuff in. So we really want to see 2 squared minus 2 to the third over 3. And that's going to be 12 thirds minus 8 thirds, 4 thirds. You could skip this and go from here to here. But yeah, some work needs to be shown. All right. Okay. Well, I think that's pretty fabulous. Hey, let's just take a quick look-see. Let's see, what are they called? We want 2009 scoring statistics, I think. Let's see. No, that's not the scoring statistics. What are they called? Well, I'm not going to waste time now looking, but yeah, they are. They are called scoring statistics, but I don't want for the BC test. I want for the AB test. So, what about changing that to AB? Okay. Oh, it loads. And what question was this? This was question 4. Question 4, the mean here out of 9 points was 4. So if you got at least 4 points on this problem, kudos to you. You're on your way to getting a 3. And if you got more than 4 points, you're well on your way to a 5. Okay, happy people. So that's, I think, a good set of practice for us. If you would like to do some more setups, I can do some more setups in this video. Yeah, we could certainly do some more if you like. So Um, I did those. Yeah, so I'm going to do some more setups. If you want to stick around, by all means. If you think you're fine with setups and have this volume stuff down, my recommendation is that you now go back and do some more footprint problems from day one, because you've probably forgotten that stuff. Okay, so today, how about y equals x squared plus 3 on 0 to 2? So my region, this is 0, 3. This is 2. 4 plus 3 is 7. Okay. And I'm actually talking about this region. Okay. About the x-axis. Okay. So if I'm doing x-axis here, I think a disk is going to be easiest. So my radius is my y value, also known as x squared plus 3. And so I'm going to integrate from 0 to 2 pi x squared plus 3 squared dx. If I had to do this by hand, I would FOIL and then do my antiderivatives and definitely pull that constant out. Okay. Shell? Well, yeah, no, I don't think I really want to do this with a shell, but I'll draw it with you. Take a look. Okay, so here's the problem with doing this as a shell. Let's say I draw my line here. And that's cool. So my height is simply 2 minus 0. Oh, well, that's great. Yeah, but if I drew my line here, my height is no longer a constant. Oh, so my height is now 2 minus x. And x is y minus 3, square root is x. So we want 2 minus square root of y minus 3. And that's pretty horrible, because wait, I had to split this up into 2 integrals. Why did I have to split this up into 2 integrals? Well, I'll show you. All right, so here, below this line, I have right minus left is a constant. Above that line, right minus left, that's a different left than there was here. And that's why I have to split this into 2 integrals. So we know that this is a y value of 3. And so I would have to integrate 0 to 3, this minus this, 2 dy. And I'd have to add that to from this y value to this y value. So 3 to 7 of this minus x, which we said was square root of y minus 3 dy. And that sucks. I would so prefer to do this happy disk than this really hard 2 different integrals, because even though this is the same everywhere, this is one right, one left, and this is the other left. Yeah, no, 2 different lefts means I need 2 different integrals. It'll still work, it'll still generate the same answer, but ugh, that'll suck. Okay, what if we go, what if we go about the, what if we go about the y-axis? Okay, so I've got this region, I want to go around here. Now, in this situation, I think washers suck. How come? The same reason in the last problem. So if I draw my washer here, it turns out it's not a washer, it's a disk. But if I draw my washer here, and so what do I notice? Well, I notice left is that, and I notice Left is now that. I've got two different lefts, so I need two different integrals here. And that sucks. So, not very keen to do this with washers. But if you really want, this is 2. So, and down here from 0 to 3, I just have r, which is this distance, 2 squared. Don't forget the pi. Yes, we're going this way, so we're going 0 to 3 dy plus the integral from 3 to 7. So we're going to go from here to here. My big R is still that constant 2. But the little r is changing, right? This is my x value. So what does x equal? Well, didn't we say that was y minus 3? So that x value is my little r. Okay, so square root of y minus 3 squared dy. Ew. I hope it's much easier to do this with shells. Let's see. So, my shell. I draw something parallel to the axis of rotation. And there we go. It looks like the height is my y value, also known as x squared plus 3, and my radius is x. So my integral 2 pi x squared plus 3 dx, and we're going from here to here, 0 to 2. Yeah, like I said, a tough washer, easy shell. And a tough shell can always be an easy washer as well. Okay, so then let's take a look at what happens if we spin this around y equals 7. So here's y equals 7. If I'm doing this with washers, my little r here, this distance is, yeah, I draw that a little misleading, so let me fix, oh no, that was correct, because we're going to 7, and we're rotating around 7. Okay, so this distance is 7, this distance is y, and so our little r is 7 minus y. Since this is going to be a dx washer, I'm going to have 7 minus x to the third, x squared plus 3. Okay, 8, watch out. So it's going to be 4 minus x squared for little r. And big R, well, big R is a constant. Big R is 7. So we're going to have the integral from 0 to 2 pi big R squared minus little r squared dx. Okay? How about with shells? Well, if I do this with shells, this is my region. This is what I'm rotating about. Oh yeah, shells is going to suck, because if I draw here, I get these where the height is 7 minus this x value. But if I draw down here, then my height is constant. 7 minus 0. Ew. Okay. These would be dy, so 0 to 3 of this constant. That's a big R. No, these are shells. This is 2 pi. The radius is this distance. This is 7. This is y. So 7 minus y That's my height. Wow. Yeah, no, in fact, this really sucks. So I'm going to have to draw it bigger and pay more attention. Okay. So we've got this around this, and we were doing this. Okay, and so our radius then is a constant until we get to, no, it's not a constant. Lorg. We're doing shells here. Blink, blink, here, this. Okay, that is y, that is 7. So big R is 7 minus y. And since this is dx, we want 7 minus x to the third, x squared plus 3, or 4 minus x squared. All right, and we're doing shells, so we need a height, and that height is a constant height. H equals 0 to 2. This height is 2. Okay, so first integral, 2 pi 2 times 4 minus x squared dx, and that's going to be good from 0 to 2 plus, like that's just taking care of all that. Now we have to do this part up here. Yikes. So my little r is there, and my big R is there. So this is y minus 3. Oh my goodness. Can we just stop? Okay, we can stop. Yeah, I think on day 6 we can stop. So I'm going to stop and say, hey, I think you're fabulous. You may need to do some more practice, but life is full of opportunities for that. Have a fabulous day, everyone.